Okay, good morning, everyone. How are you doing today? Good morning, online. Good morning. Okay, so hope everyone are doing good. Did you guys complete it? Practicals? What topics were those? Ingress controller, sidecar. What's that? Environment variables, config maps, and secrets. Config maps, secrets, sidecars, right? And then ingress controller. Completed, huh? Nice. How about you online? Online, no replies. Online, can you hear me? Or everyone are thinking that that question is not for me. Huh? Okay, complete it. Okay. So today, let's go with the next topic. Pods scheduling. What's that? Pods scheduling. So remember, we already learned about the jobs and then scheduling. Remember? Do you remember the three types of jobs? Non-parallel, parallel with fixed count, and parallel with the last one, work queue. And then also we discussed about the cron job. Remember cron job? That also done. So this topic could have told there, or that topic could have discussed today here. So, but here I just put it here a little bit different because this is completely alag, different. So pod scheduling here is we have three types here, Nana, three types of mechanism. As the name clearly says, pod scheduling. Say that. Pod scheduling. Pod scheduling meaning here, who will schedule our pods? Scheduler, right? Who will schedule the pod? Scheduler. Scheduler will schedule the pod into the worker nodes. And to schedule that, this scheduler has mechanisms, three types of mechanisms. So the cube scheduler will decide in which worker node the pod should get created. Yes or no? So this scheduler has three types of mechanisms. Say with me, node selector, node affinity, taints, and tolerance. Say that. One more time. Three types, very, very important. What are those? Node selector, node affinity, taints, and tolerance. As the first name clearly said, node selector. So our cube scheduler is selecting the node. So what we do is, first of all, we will label a node. We label a node. And then the scheduler, in the manifest file, will tell, hey, the pod should get created only on the worker node, which is labeled as this. Example, you guys are all coming offline people to my class here, room number 202. So 202 is a label or not? So in the downwards, admin will be there. He will be redirecting you to go only to 202. So this is the room selector. What is this called? Room selector. Yes or no? యాప్ చేసిన నువ్వు ఎందుకు చీకటి అంటే ఇష్టమా? Okay, it's coming up probably. So I was saying, right, room 202, that is a selected room for all of you. Yes or no? Similarly, here also node selector, meaning we will label the node, and whichever in the manifest file, if we mention that, hey, the pod should get created only in this particular node which has this label. So our scheduler will go and schedule only onto that particular node. Assume we have how many nodes? How many worker nodes we have? 2 worker nodes. So did I label anything? Did I label anything till now? No. I didn't label anything, but if I run a manifest file putting a label, so pods will get created? No. Pods will not be get created because you are telling in the manifest file that the pod should get created only on the node which has this label. So scheduler will go and check label is there or not. If the label is not there, pods will not get created. So when this will be useful in your real time is, for example, we have some criteria like, only dev pods or dev pods need to be created only on dev node server, on prod node server, or you can mention that memory which has a big memory. You can mention that label as huge memory, label as huge memory, and then you can categorize this, right? So that is called what here? Node selector. Say that. Node selector. Okay. It means pod should be already created before getting selecting for scheduling. No, pods. Why the pods will get created before? So now let's take this deployment. Node selector. Okay. This is clear. Node selector dot YML. Can you see that and tell me is there any difference there? Hmm? There is a mistake there. Here I need to put colon. So here, what do we have mentioned here? Node selector. In the manifest file, I mentioned a specification saying that node selector, node name is IB node, internet banking node. But did I label IB node? Did I label till now any node as IB node? No. So, but I have mentioned in the manifest file, how many replicas? 2 replicas, 2 pods should get created. On which node? IB node. But did I mention any node? No. So will this get created? Let's see. Okay, tell me how to do that. kubectl apply or create -f node selector. Okay. kubectl get pods. In which state it is? Pending. Did it created anywhere? No. It is still in the pending state. Why no? Yes. But now you don't know about the node selector. Someone gave this manifest file and then you ran it. And then what you got, you see here, it says pending. How do you check it? How to check the errors? kubectl logs. Guys, this is not in the running state yet. So if it is not in running state, do you get any logs? It's not generated yet, right? What is another? That is, okay, kubectl. Describe. Very good. What is that? kubectl describe pod and the pod name. Okay. Can you find out the error? In the bottom, events are there, no? So it clearly says message 0/3 nodes are available. So, Okay. One node had untolerated taint, blah, blah. I'll talk about what is taint. Okay. Two node. Okay. So we have three nodes in total. First one is master, right? And second two are worker node. Does the master will take any pods? Master will take any load? No, because that is tainted, but I'll talk about that concept. So here control plane is already tainted. Okay. And then two nodes didn't match pod, node, affinity or selector. Here we have mentioned as node, affinity or node selector. There are three mechanisms. What are those? One is node selector, node affinity. Last one, taints and tolerance. But it clearly says two node didn't match pods, either node affinity or node selector. So, and then because it clearly says that the two nodes didn't match the pod node affinity. That meaning here in the manifest file, we have given a node name called IB node. So that is not matched with any worker node. That's why it didn't created any pods. That is the reason. So now what I need to do for this then? We need to label it or not? We need to label it. So we need to label it for what? Pods or do we need to label for node? Node. What's the command to list the nodes? kubectl get nodes. So we have these nodes now. Let's take the first node C7. Which one? C7. Let's edit this node and we label as IB node. We label as what? IB node. What's the command to edit? kubectl edit node. Which node? Remember I'm editing C7. Which one? Okay. Visible, huh? So here, do you see we have the labels section here? So go inside the label section, come to the last part, go to insert mode. And then here you need to mention node hyphen, or that node hyphen name. What did you have given here? Name, node hyphen name. What is the node name? IB hyphen node. Now the node got edited. So did we label the node? Yes or no? Or else you can use the command also to label it, no issues. But I directly open the node and then edit it. But you can write a command also to add a node, to add a label. So now it's got edited. So what do you think our pods? Now it is in pending state or running state? Pods are in which state now? It will be running now. kubectl get. Do you see that now it is in running state? You understood now? I told you ulta concept. That means first what we need to do? First label it and then create it. So if I label and create it, you don't get maza because it's normally creating, sir. What is the difference? Then what I did? I just created I ran the manifest file, created the pods. The pods are not in running state. Then I label it. Then it start running. This is called node selector. Okay. Describe kubectl get pods -o wide. Okay. Okay. Can you tell me here in which node this got created? These the two pods? C7. We have edited also C7. Guys, understood? Okay. You're not able to see? Okay. Do you see this is so the two pods are running. Those are running on C7. C7, C7. Because we have labeled the C7 node as IB node. Is this clear? Online clear? So let's delete the deployment again. So let's go kubectl, delete, deploy. Which one? IB deployment. Okay, delete. So what's the next topic here? Node affinity. Say that again. Node affinity. In node affinity, we have two types now. Node affinity is also related to the same mechanism, but it has a more expressive way to specify rules about the placement of the pods. So first of all, the first one is what? Node selector. What we mentioned? We mentioned that node name is this and it is created directly. Will it create it in the second one? No. So if the node names are not there, will it create any pods? It will not create. It's very strict or not? Node selector is very strict. That meaning if there is no label, scheduler will not schedule the pods. Simple as that. Very strict. Coming to the node affinity. What's that here? Node affinity. There are two types here. Preferred during scheduling, required during scheduling. Say that. Preferred during scheduling. Or else you can simply say preferred, required. Say that. Preferred, required. As the name clearly says, preferred, required. Which one is hard? I mean, which one is strict? Required. Required means it's same as our node selector. If there is a label, go and schedule it. If there is no, just stop it. Don't do it anything. But whereas the first one is what? Preferred. Preferred meaning first check. If not, go and create wherever it is. So it is like soft, like me. Why are you laughing? It's correct only, no? Right? So here, preferred and then what? Required. Preferred meaning it will try. So that's why I wrote it here. Good if happens. What's that? Good if happens. So if you mention preferred and then give the label, so our scheduler will go and check label is there or not. So if label is not there, it will go and create or schedule in some any of the node. Right? But whereas if you put required, it is same like your node selector. But the difference here is it has a lot of syntax. It says in, not in, exist, operators greater than, less than, does not exist. This kind of operators will be supported by node affinity. So does the node the node selector supports any operations? No. So which one will select the operations? No. Which supports the operations? Node affinity. It's a more expressive way to specify rules. Got it now? So which one is commonly used? Our node affinity or node selector will be commonly used. In the node affinity also, we have preferred and then required. Okay. Now I'm going for this. Correctly you tell me what this guy is doing. Okay. I'm going for what? Preferred dot YAML. Okay. See this and tell me what happening. Top everything is fine. Do you see what did I mention here? Node affinity. And it is what? Preferred during scheduling. Okay. So see this part and tell me where the node will get created or what happens with this. Will it create a, it will not create a, or it will create in anywhere, any node. Hmm? Hmm. The parts will create or not? Hmm? Hmm? Okay. So parts will get created? Sure? Okay, I'll give 1 more minute. Check it. How many parts will created? So what you're saying is one part will get created. Where? The other one. Not C7, other one. Huh? Should we check it? Huh? What is the node name? MB-node. Do we have any label with that? We don't have label. So did I mention preferred or required? Preferred. So preferred meaning it will check whether MB node is there or not. If not there, it will create it in any of the node. Doesn't matter. It will create it the second one. It can create on first one also. Let's see. Okay, run it. First of all, kubectl get pods. Do you have anything? No. So let's go. Kubectl apply -f. Which one? Preferred. Kubectl get pods -o. Wide. Where it is getting created? C7. C7 meaning it has the node IB node, right? But it is creating anywhere. Got it? You understand the concept? Right? So preferred meaning it doesn't matter. It will first check MB-node, whatever the label that we have given. First, it will check the label is there or not. If label is not there, then it can create, the scheduler will schedule the pod in any of the node. This is concept. Online clear enough? Okay. So if I edit, it's Kiran. If the two nodes have the same label name, it will select any of the one. Simple as that, no? Okay. If I go ahead and then change the node name IB node to MB node, then what will happen? It will create exactly on that node or not? What I'm saying is MB-node is labeled now. It's not labeled on any of the node. But what I do, if I go and label any particular node with MB-node, what will happen? If I run this, container will create exactly on that machine or not? Yes, that is called preferred. What is that called? Preferred. So let's delete it. kubectl, delete, deploy, IB-deployment. So what's the next one here? Required. What's that? Required. Now tell me, will this get created or not? Online. Online? Why are you so silent? Lot of Kubernetes? Hmm? Guys, why I'm going very deep of the Kubernetes and taking long time, because the future that everything that we go with is only with microservices, Kubernetes. Okay? That's the reason why I'm taking each and every topic slowly, explaining it. So concentrate. So only Minhaj is there. Rest of the people are not there. Huh? Tell me, Nana, will it get created? Yes or no? Absolutely yes. Okay. So exactly what you said is okay. Let's see. Let's go and create kubectl, create -f. Which one? Required.yaml. So kubectl get pods -o white. In which state it is? Pending. Will it create? No. Why? because there is no MB-node. That's the difference between preferred and then required. So previously I gave MB-node. So it tried to check MB-node label is there or not. As it found that it is not there, then it has selected any of the node and created the pod and it is running. Yes or no? So now here I have selected which one I have used required. Required meaning it will check the exact label is there or not. If the label is there, it will create. If label is not there, it will not create because we have given the property as required. Clear? Online. Those who said yes, it's clear. Good. So what is the next topic here? Taints and tolerance. Say that. Taints and tolerance. So taints and tolerance are like, this is the old method. People, if required, use it, otherwise no. But the concept, see, the previous concepts like node selector, node affinity are guaranteed, yes or no? That meaning if the label is there, it will create. If not there, it will not create. So if you use preferred, if label is there, it will check. Otherwise, it will create in anywhere. So you know what is happening. But coming to this taints and tolerance, same labels concept only, but it will not guarantee. There is no guarantee that the pods will be created only on the particular node. It's no guarantee at all. That's the reason why. So taints and tolerance basically is less used because we have, which one is very commonly used? Node affinity will be commonly used. So, but here I'll be teaching you taints and tolerance. Taints and tolerance is similarly like your, what is it? Key and lock. Lock and then key. So if you have a lock, if you put the required key, then no, you'll get open. Yes or no? And if you put the other key, will it open? No. So similarly here also. So taints meaning the node will get tainted with one label. What's that? Node will get tainted with what? A label. Right? And then in the manifest file, we'll put the tolerance. If you put the tolerance as, see, so tainted, let's say for example, for the worker node, I tainted. Tainted means labeled here. Because this is an old concept, right? Old concept, we call it as taint. So I tainted a worker node as some label. Then in manifest file, I need to mention the tolerance. Taints is on the node level, tolerance on the pod level. I mean manifest level. So in the manifest file, if you mention the tolerance, that you have mentioned the taint label here, then only it will get go and create over there. If you not mention any tolerance, will it create the pod? Answer is no. So here it says, in Kubernetes, taints and tolerance work together to control the scheduling of the pods onto the nodes. Taints are applied to nodes to prevent certain pods from being scheduled on them. Let's say, for example, there is one node. I mentioned the taint as maintenance. I mentioned the taint as what? Maintenance. Will the pods will get created on that particular node? No. So you need to mention. So generally, if you don't write anything in the manifest file, it will not, that the scheduler will not schedule on the particular node because that is tainted as a maintenance already. But in the manifest file, you mention the tolerance as maintenance. Label is matching. Then only the pods will go and sit into the particular node. Let's say, for example, another example I'll take. There is a machine type, powerful machine type. What is that? Powerful. It has a hardware, a huge hardware. Let's say mainframes or some kind of big kind of framework, Hadoop related things. So I have a pod. So I need a pods, only the pods that should be scheduled on the particular node. Can I taint it and then tolerance it or not? Right? So I only, let's say for example, Hadoop. Let's say there is a worker node called Hadoop worker node. I want only the pods which is related to Hadoop only to work on, to schedule on there, no one else. Let's say other people, what they write their manifest file, but do they mention the tolerance? No. They will not mention the tolerance. If they don't mention the tolerance, the pods will never schedule on that particular node. But if you mention the tolerance as Hadoop, then the pods will actually go and schedule inside that node. Let's say one more example. We have 10 worker nodes. On that, 2 worker nodes I need to take under maintenance. So is it good that our master node schedule the pods into the 2 nodes, maintenance nodes? Then how do we do that then? Taint it. So on the node level, what we do? We taint it. So our customers, users, those who are writing the manifest files, do they mention intolerance? No, they don't mention. If they don't mention, obviously scheduler will check that is tainted as maintenance. Whichever the matching label is there, then only the pod will get created. But in manifest file, matching labels are there. Tolerance here, instead of labels, we call it as here what? Tolerance. Matching tolerance is not there. That's why the pods will never get created on those 2 nodes. So taints is on the node level, tolerance is on the manifest pod levels. If you mention, then only it will get created over there. If you don't mention, it will not get created over there. That will get skipped. Okay. So as I said here, taints are applied to nodes to prevent certain pods from being scheduled on them, while tolerance are applied to pods to allow them to be scheduled on the nodes of matching taints. Yes or no? Okay. So this is node 1, node 2, node 3. I tainted as Hadoop. I tainted as maintenance. I tainted. Tell me one more. Huh? Big data. Hadoop is same, no? Spark, okay. Something, some names. So I'm writing a manifest file here now. Manifest, yeah, 1 YAML file, 2nd YAML file, 3rd YAML file. There is one more node, which there is no taint. No taint. So in 1.yaml, no tolerance is mentioned. No tolerance is mentioned. Okay. In second one, tolerance I mentioned as Spark. In third one, tolerance I mentioned as Hadoop. Okay. Now tell me, first one where it will get created? This one where it will get created? Online. Exactly. Yes or no? Will this 1.yaml file will get created on this 3? On this 3? No, it has mentioned this is the lock and this is the key. Now the second 2.yml will be created where? This one? Understood? No? Same. This is called taints and tolerance. So taint is on the node level and then tolerance is on the pod level. Good. And okay. So what we do is we'll go and edit one node, right? Yeah. You know, right? I told you that master does the match, sir, maintenance will temporary. Yes, maintenance is temporary. I then remove this taint. No, if you remove the taint, the parts will get scheduled over there or not. It's up to you. You can remove that again. Okay, see here. Does the master node will take any load? Parts will created on the master node? Answer is yes or no? No. Why? Because it has been tainted as no schedule. So till now I told master node load will not take, master node pods will not get created. Why? Because it's already tainted as no schedule. Say that. Tainted as what? No schedule. Okay, let's go and edit and I'll show you. kubectl get nodes. Okay, kubectl. Which one? Guys, tell me. How to edit the node? Edit node. Which one? I am opening this. Okay. So, do you see this here? Taints. Effect is what? That meaning our kube scheduler will first check the taints. If it is effect, the taint is there, effect is no schedule, the pods will not get created onto the particular nodes. If it is under maintenance, can you also put like the same thing or not? There is a worker node 10 is there. You don't want that pods to be get created over there. Then taint as no schedule. Got it? So this is the reason why we have master node will not have any what? Pods. Guys, is this clear? Online. So let's try to apply a taint to some node, right? I consider as some high performance GPU nodes, right? Taint the GPU nodes, for example, to repel force pods do not require GPU resources. So here I'll go and open I'll go and taint one node with the name, with the label called what? Hardware is equal to GPU, and I'm putting what here? No schedule. So that meaning if I don't mention anything inside the manifest file, so will it get created over there? Answer is yes or no? No. So this command adds a taint with a key called hardware, value as what on here? GPU, and effect is what? No schedule to specific node. As a result, pods without a matching tolerance will not be scheduled on this pod. So if I go in, let's go and taint it. Okay. So what's the command? First, let's get the nodes. Which nodes are there? kubectl. Say that. Taint nodes. To which node will taint? This one. 82. Let's go and taint this guy. So, and then what I give, you can give any name. I'm just giving the key as hardware and then value as GPU. And what's the parameter I'm using here? No schedule. So guys, we have no schedule, prefer no schedule, no execute. There are three models are there. Three effects are there. I'll talk about it. So here, but here, what is the effect I'm putting here? No schedule. No schedule meaning normally pods will get created over here. Tell me guys. A little bit concentration. Generally, if I put no schedule here, by default pods will get created over here. No. But in manifest file, if I put a tolerance as hardware is equal to GPU, then pods will get created over here. Okay. So see, I tainted and it clearly says this node has been tainted. So now let's go and use this manifest file and see. But do you have any kubectl get pods? Nothing. Okay. So let's test it now. Test.yml. So guys, can you see this and tell me, will the pod will get created or not? Will it schedule on that 88 or something, the node? Will it schedule there? Will it schedule on the other one? For sure, it will not schedule on the 88 something. But will it schedule on the first one? Do we have any label? Do we have any labels here? We have taints and tolerance here. Okay. Tell me. The question for you here is, will it schedule on 88? Yes or no? No. Will it schedule on the first node then? Yes or no? Online. Okay, pod will, so what you're saying is pod will never get created. That is your question, right? That is your answer, huh? Okay, let's go. Go ahead. kubectl, create hyphen f test. Created, huh? Then kubectl get pods. First of all, I do get nodes. And kubectl get pods hyphen o wide. So as per your thing, it should get no pods, right? One pod is running state. Where? What is the concept of taints and tolerance? The second 188 has been tainted as hardware is equal to GPU and then no schedule. So what happens whenever you write a manifest file, if you don't mention anything, generally if you don't mention anything, pods will get created. But will it get created on the tainted one, which is hardware is equal to GPU? No, because tolerance is not matching. No. That is the reason why scheduler will go and schedule on the another node. But okay, now if you want to schedule it in the second 88, then what I need to mention in the manifest file? Tolerance, you need to mention hardware is equal to CPU. Then only it will go and schedule over on the second node. Understood? Online, got it now? So now what I do is I'll go and add it. Let's go and delete this. kubectl delete hyphen f. Which one? There's what I deleted. Do you have any pods here? That's terminating. Okay. Now what I do is I edit this. And then here we can add the tolerance now. Right? So instead of writing time waste. So now I'm adding the tolerance here. Okay, see here now. Previously node got created in C7, no? But we have tainted for on 88, no? Now see this manifest file and tell me where the pod will get created. You're getting? Where will get created? 88, huh? So do you see tolerance here I mentioned? And then key is what? Hardware. Operator is equal. What is the GPU? Effect is no schedule. This is the same way that we have tainted that one also or not? Okay. Now let's go ahead and then kubectl create hyphen f test.yml. kubectl get pods hyphen o wide. So your expectation is on 88. Get nodes. Or is that 88? 88 to something, right? kubectl get pods hyphen o wide. Why not guarantee? Why not? That is why we are not using taints and tolerance. I need to show you practically, no? That's why I took this much time to explain. So because it depends. Sometimes it will go and sit on the 88 only. But here, so as taints and tolerance is not guaranteed, for that reason here we are going for node affinity all the time. So whenever you see the taints and tolerance, remember, so it will go, but sometimes we cannot guarantee, like how we are not lucky now. That's why it is not guaranteed. It's not on 88. It went to C7. Clear now? Online, is this clear? Nice. Okay. So now what we do is it clear till here, everyone? They will, Kiran. Don't get angry. Okay, let's delete it. Keep it here. Delete. -F. Which one? Test. Okay. So now let's do a small project. Okay. It's not small. It's a very important project. It's not lengthy. Do you remember since AWS, I was telling you how to deploy an application within the blink of eye. What model is that? Blue-green deployment model, right? I showed you on the EC2 front end also. I showed you on the RDS also, right? I showed you on the multiple EC2, I mean Beanstalk also, right? I multiple places I have shown you how to do the blue-green deployment. And as we are using this Kubernetes in real time, in Kubernetes also, I need to show you how to do the blue-green deployment or not. Are you ready? Huh? So let's go and do the blue-green deployment model. So you know about that model already. So make sure the first environment is running first. Okay. Make sure the first environment is running. And I'll give this URL to everyone. Online people are our customers, right? So we'll do the deployment first of all. We'll go with the IB image, internet banking image. Okay. We'll create a deployment. You know the manifest file for the deployment for IB image, but and then we need to create a service also or not for that? Yes or no? So we need to create a deployment, and if you want to expose that application to outside world, we need to create what? Service with which one? With load balancer. That is first environment, and I'll give this load balancer to online people. So everyone will able to access on my internet banking image or not. Now, without any downtime, I need to change that to mobile banking. For that, what I do? I'll create one more deployment, one more service, one more service. Then I need to switch it. So here also we use a concept called labels. What's the concept we use here? Labels. Should we do this here? Guys, clear concept? Online. So let's go ahead and then create our blue environment. Ready? Let's do. So vi blue.yml. So here I'll take the same thing. Okay. Do you remember? Should we write? You remember? Let's go. API version app/v1. Okay. Next. Kind what we use? Deployment. Okay. Next. Meta data. Very good. And then name, I call it as my app blue. Very good. Next is what? Labels. Guys, any spelling mistakes, let me know, okay? Then I call it as app. That is going back. See, idiot. App. I call it as my app. And then here, here one more label I'll put. I call it as which version is, I call it as blue. Because I need to identify this as a blue, no? Right? Okay, good. After that, we need to write what? Spec. Wow, man. Replicas. How many ago? 3. Okay, next selector. Selector, match labels, and then app my app. Okay. Next here, version. Which version? Blue. Okay. Next now. So template should be here. Template. Oh man. Okay. Labels. App. My app. And then here, version. Version is blue. Next step. Okay. This spec should be under spec inside it. Containers. Next, hyphen name. What's the name? My app. And then image. I go with trainer ria / which one? IB hyphen image colon latest. Next here, can I expose ports? Right port. What's the container port? Container port is 8. Observe these ones. You only told, but try to. The only difference is here version. I put it as what? Blue. So whichever the pods, how many pods will get created? 3 pods will get created, and all these 3 pods labels will be app as my app, version as blue. Okay, now nice. Let's go and create. I will create. Okay, you can create in the same thing, or you can create it in the other one also. No issues. kubectl create -f blue.ml. So no syntax issues. Very good. So now we need to create a service for blue or not. So what is that? blue-service.yml. Go ahead. So do you remember how to create a service? Go ahead, Nana. API version. Here V1. Very good. Next, kind capital letter service. Next up, metadata. So metadata name is my app service. Okay. That's what, here no need. So go with the spec, and here I call it as selector. So here we need to mention app as what? My app. And what's the version? Here the service. Listen, this is a very important switch. Here the service, I'm creating a service. This service will redirect to which pods having which label? Version as blue. So there are 3 pods are running, and what's the label for that? Version as blue. So when I create this service, so service will redirect all the requests to blue. Now if you want to switch it, instead of here version colon blue, I need to switch it to green. So remember this service, this is the place where we switch later. Okay, version. After that, ports. So ports hyphen protocol. Okay, TCP. And then here what? Port. Port number is 80. And then we have what? Target port. Target port, I call it as 80. And then the Bhayanak wala type is what? Load balancer. See these ones. What did I create Nana first? I created a deployment, which one is that? Internet banking application. And then I created a service. The same thing that you have done before, the only difference I put it was label as version blue. Okay. So let's go and create kubectl, create -f, blue hyphen. Service got created now. Okay. What's the command to see the service? kubectl get service. Wow. Do you see our load balancer? So let's wait for 2 minutes because load balancer need to get active, right? So, and then we'll give this URL to everyone, right? And then what is the application that they will see? Internet banking application. So let's wait for a couple of minutes. Okay. So if I go to the load balancer, what is that? A5, no? A5. So which security group it is using? This security group. Let's see. As everyone need to access inbound rule. HTTP, everyone is there or not? So that's fine. Wow. Do you see? Internet banking is working online. Open this URL and confirm. Deployed. So now, online, please confirm. Super. It's working, right? Okay. So now, our deployment, our blue environment is ready and everyone are accessing nicely. Now, what I need to do? I need to change that internet banking to mobile banking. So for that, is it good to go and modify the existing one? No, we'll create a separate parallel. So we need to create green.yml. So it is the same thing like blue only, right? Blue.yml. Instead of writing, I'll grab this and I'll write green.yml. So what are the modifications that we need to do? You tell me. Name. Let's go on from top. Name is green. Version green. Of course, we use sed command. We can use sed command also, right? Here we need to change to MB. Clear? Okay. So run it. kubectl create -f green.yml. So our green.yml, this is fine, is working, right? Now what we need to do? We need to create a blue service. We need to create a, do we need to create a green service? Do we need to create? I'm not asking, so do we need to create or what I mean to say is we created blue deployment, we created a blue service. So now here I created a green deployment. Do I need to create a green service here? Not required, no. So we already have a service. Which one is that? Blue service. Now, if you want to switch it, now what I need to do? Edit that blue service and change that version blue to green. Let's do vi blue -service. So instead of this blue, simply switch it to green. So we need to apply this or not? So do you need to create or apply? Apply -f. Which one? Blue -service. Applied. Now online. So if I refresh, so this should become to, let's see, and change to mobile banking. Any downtime? That is the power of blue-green deployment model. So now you also completed how to deploy the applications using the blue-green deployment model. Right? There are 3 types of deployment models, Nana. Number 1, rolling update. Remember, we have done the rolling updates. By default, it is rolling update. Where we created on the replica sets, right? And then we have roll out, roll back. We have done, remember? And then the another one, which I didn't say it is recreate. What's that? Recreate meaning it will roll out meaning, let's say, for example, you have 10 pods running and you have updated to the latest version using deployment. Remember, that's the problem with replica set, right? Replica set cannot do the rollouts and roll in. Remember, which one will be deployment is the one which will do the rollout and rolling. So you have changed the image, and what will happen? Existing all the pods, new pods will get created first, and the old pods will get deleted. So will it delete all at the same time? No. If you want to delete all at the same time, that is recreate. Rolling meaning one by one. One pod will get created, one pod terminated. One pod created, next one is terminated. That is rollout. That is rollout. Next one is recreate. Next one is the blue-green deployment. Deployment models in Kubernetes. Yeah. Online, is it clear? Guys, will you able to do this here? Clear? Good. So if I want to delete all, what I need to do? kubectl delete -f. I put what? Boom. All are deleted. The rest of the node selectors are all deleted already. All are gone. Don't do that in real time. Okay. Very dangerous command. Okay. So superb. That was on the blue-green deployment. And the next topic here is Helm. What's that? Kubernetes is not completed. So Helm will come under still Kubernetes only, right? So to give you a little bit info about the Helm. So we have only 15 minutes. Other people exactly they'll come at 10:30. I'll just give an intro about the Helm. Helm. Guys, what is the package manager for Red Hat? Yum. What's the package manager for Ubuntu? I mean Debian app. Now you tell me. What is the package manager for AL2? Amazon Linux Extras. That is for Amazon Linux to AL2. So what is the package manager for Kubernetes? Helm. So Helm is a package manager for Kubernetes. Similarly, how we have yum apt Amazon Linux Extras. Similarly, here also we have in Kubernetes, we have what? Helm. So Helm has something called charts. What's that? Helm has what? Charts. What is a chart? Chart is a collection of manifest files. Chart is a collection of what? Manifest files. So how we have the Docker Hub where it has all the images, right? Helm also has something called repositories. What is that? Repositories. So those repositories contain what? Charts. Guys, link is important. How we have Docker Hub? In Docker Hub, we have the images, right? We have the repositories also, images also inside it. Similarly, Helm also has what? Repositories, right? Helm also has repositories. Inside that repositories, they have what? Charts. They have what done here? Charts. So if you want to install any particular, let's say if you want to install Nginx in Red Hat, what's the command that we use? Yum install -y Nginx or Apache. If you do yum install -y Apache or HTTPD. How does our operating system knows HTTPD? Operating system doesn't know HTTPD, right? Because why it knows? Because it has the repositories in the backend. What it has on a repositories. That repositories contains the information about Apache. Similarly here also, so Helm has repositories, and that repositories has what? Charts, and that charts has what? Manifest files. Let's say for example, if you want to install anything, we use yum install. But here in Kubernetes, if you want to install anything, you need to use Helm. What do you need to use? Helm. So Helm in Kubernetes, Helm is a package manager to install what? packages. To install what here? Packages. Like how we have yum apt for Kubernetes, what we have? Helm. So it is used to install application on the cluster. So we can install deploy application using what? Using Helm. So using Helm, we can install applications in Kubernetes. Guys, what is the monitoring tool that we're gonna learn? Prometheus and Grafana. So we can use Helm to install Prometheus and Grafana also. And also after this, we have something called Argo CD. Say that. Argo CD is a deployment tool for Kubernetes. Say that. Deployment tool for Kubernetes. How we have Jenkins? So we have integrated all the tools with the Jenkins or not? But Kubernetes, I will not be integrating with Jenkins. Because Kubernetes, we integrate with Argo CD. Argo CD is a GitOps tool, GitOps or Git operations, whereas all the manifest files, I'll put it in the Git repository. When I do any manifest files changes in GitHub, automatically my Argo CD will identify and it will create the pods automatically. Same thing Jenkins is also doing or not? What the Jenkins is doing? Is there any, if they're using webhooks, right? Whenever there is any modifications in the file, whenever there is a new commit in the repository, in the GitHub, Jenkins pipeline will start or not automatically. Similarly here also, right? In the real time also, here we are also in our company, we are also using Argo CD. We will maintain all our Kubernetes manifest files in GitHub. And whenever you modify any new commit inside the GitHub in the particular repository, which is having the manifest files, automatically Argo CD will pick up and then it will deploy a new pods or new service based on what you have written in the manifest file. So that one, the deployment I'll be showing using what? Argo CD for the Kubernetes. Got it? Okay. So architecture, Helm repository is there, Helm client, API server. So here we will go with Argo CD. How do we install Argo CD using Helm? What's that? How do we deploy Argo CD with Helm? So we can do it. So now Argo CD is, as I said, it's a continuous delivery tool for what? For Kubernetes. So Argo CD is a core component of, there is a separate Argo project is there, right? Using this, we can continuously, what we can do? We can do the continuous deployments for the Kubernetes using this Argo CD tool. So for that, what we need to do? We need to install the Helm. Using Helm, what we do? We will go and set up the Argo CD. Using Helm, we'll set up the Argo CD. Okay. So for that, what we need to do? We need to install what here? Helm. After that, we are giving the permissions. We are running the file and the Helm will be installed. Guys, see here. After that, we need to install what? Argo CD using Helm. See here, how to install any package or application using Helm like this. First, we need to add the repository or not. Every application have their own repository in the Helm. Right? So here, you can go, right? So chart repositories will be there. So this is a place where, okay, these are Alpine charts are there, right? So Argo CD. Do you see this here? GitOps CD. So Helm Git. So this is the manifest file to set it up. So this is also how what every application will have their own repository. What we are doing, Helm repo add, and then we are adding the repository, and then we are updating the repository for any kind of new updates. After that, what we do, Anana? We are creating our own namespace. Yes or no? It is always good to create your own namespace for every application in Kubernetes. Please don't use the default namespaces. Okay. So after that, what we do, using Helm, we are installing the Argo CD in which namespace? Argo CD namespace. Once you install, what will happen, Anna? Automatically load balancer will come. Right? So get that load balancer, patch it to the, I mean, if it is using cluster IP, then we'll patch it to the load balancer and we'll use that load balancer. If you open the load balancer, what will happen? Argo CD application will open and there we will do the modifications. We will connect to the GitHub in the backend. And whenever we do any modifications in the GitHub, Argo CD will pick up and then do the deployment. So how do we do this deployment? We can do it, but let's not hurry. We have 10 minutes. Let's not do it. Okay. Let's do it. No, huh? What do you say? Okay. People are saying no. Why, Kiran? Overloaded. What is the so okay, tell me, what are the concepts that we learned today? Pod scheduling. What is the concept we have learned? Pod scheduling. So in the pod scheduling, what are the mechanisms that we have? Node selector, node affinity, taints and tolerance. In node affinity, again, we have two mechanisms. What are those? Preferred and then required. So after pod scheduling, what we have done? Blue-green deployment. Only two topics, huh? And we discuss about what? Hell. Clear, huh? So tomorrow what we do is, we go and set up this hell, and then we'll set up Argo CD, and then we'll connect this Argo CD with the GitHub in the backend. And whenever we do any modifications in the GitHub, Argo CD will pick up and then do the deployment for us. We'll do this. Okay. Any questions? Should I give you a project to you? Will you able to do it? Okay. Project. Do you remember I told you about MongoDB Express and MongoDB project? How can I waste the time, huh? Sit it here. Don't worry. I wrote everything line by line. Notepad is there. And see here. Guys, so this is complete application setup using Kubernetes component. It's a demo project for you. It's not demo, it's a project for you. I don't know why I wrote. This is how the actual projects will be done on Kubernetes. See, this is front end. What is this here? Guys, this is front end, and this is what? Back end. So front end, what we have, this is the application that you get. We call it as Mongo Express. Say that. Online, put in the chat, Mongo Express. So Mongo Express meaning from here you can create the databases, you can delete the database, you can manage the databases. The actual database in the backend is what? MongoDB. Say that, MongoDB, front end is Mongo Express. So those who don't know how to write the queries to create the databases, they use the Mongo Express and create the databases. So it is the application only, right? So this is how you need to set up. So what you need to do, front end need to talk to whom? Back end. So it need to request to the database. So this concept includes, this project includes, what are the things that it includes? See, this project architecture includes how many deployments you need to do here? 2 deployments. One is for front end, another one is for back end. And front end, you need to create one external service or not? For whom? Front end meaning here Mongo Express. For Mongo Express, you need to create the service using the load balancer or using a node port, your wish. And then you need to create a deployment.yml. Remember, for what? For Mongo Express. And then this Mongo Express need to connect to whom? MongoDB. MongoDB is which external or internal service? It's a database, right? Database is always internal. And then your Mongo Express need to connect to the database or not? How do they connect? Using config map. Remember yesterday we learned. And then we use what? Secrets. For what? DB user and DB password. So for this architecture, you create 2 deployments, 2 services, 1 config map, 1 secret. And then the workflow should be like this. The workflow is whenever someone open the Mongo Express, the front end application, that is external service, this will go and talk to the Mongo Express pod, and the pod will go and connect to the MongoDB internal service where we have the pod of having the database MongoDB. And how does it get connected? How? I didn't even know the shortcut of removing that. Okay. Guys, so here what we have, Mongo Express, and Mongo Express is an external service where the Mongo Express is running on the pod, and that pod go and connect to whom? MongoDB database in the backend, which is running a pod using the internal service. So the internal service will talk using the secrets and then config maps. You understand the project architecture? This is how we do it, front end and then back end also. So most of the people will teach you only the front end. So here I'm giving the project with the back end also. What I do, I'll share this notepad to you. I wrote nicely in everything here. So do not blindly copy paste and run it. Please try to understand each and everything what it is doing, right? And try to, and I've explained all these things also here, and try to do this. Okay, Nina? Online? Very nice. Okay, so what is your task? You have two projects. One is Blue-Green Deployment Project. Another one is Mongo Frontend and Backend Mongo Express Project. And then pod scheduling you need to do. Okay? Good. So if you don't have any questions, can I give the final CC for today? And tomorrow we'll go with what? Argo CD. It's very simple topic. Let's go with Argo CD tomorrow. Good. Okay, so that is all for today. Let's connect tomorrow with the next topic. Until then, take care. Have a nice day. See you tomorrow, guys. Bye-bye.